Hello, my name is Trisha Hitchings, and I'll be showing you how to derive a tree algorithm in Weka using cat adoption data from Austin Animal Shelter. This data can be found on Kaggle. Assuming you have Weka open, navigate to the file that you will need. I'm going to start with Model 1. And this data is original other than some cleansing that I had to do. It has 7 variables. Age upon outcome, which is how old the cat was when they were adopted, so weeks, months, years, the type of breed, the color of the cat, the sex of the cat, if they were spayed or neutered, age category, which is what I added, but you can see there's kitten, young, adult, or senior, and the outcome for the cat if they were transferred, adopted, or returned to their owner. You can see down here in the bottom there's been bars and colors that have been changing as I click on the variables. So the colors are based on the class which you choose here, and I have outcome chosen, and the bars are the frequency of each of the variables. So we can see that transfer is blue and adoption is red. And if we go to spay or neutered, we can see a lot are, I think this was transferred, but of the ones that are spayed and neutered, a majority of them are adopted. So we can see that being spayed and neutered does impact if the animal will be adopted. So if we come over here, we're going to choose trees and then choose J48. The default is a 25% confidence interval, and then 2 items per each leaf. And then we're going to look at the percentage split. I'm going to start with 50-50, which is 50 for testing and 50 for training. And then we're going to run the outcome. So we can see at the top, if we start up here, here's the beginning, and here's where the tree starts. So this is going through all the iterations of all the variables, and they're given outcome. So if we keep scrolling, we can see that the number of leaves was 556 and the size of the tree is 578. And the outcome was 72% accurate. And if we look down here in the confusion matrix, we can see about 5,000 of the transfers were classified correctly, but about almost 1,300 of them were classified as adopted when they were actually transfers. So I tested the data over a 60-40 and a 70-30 split as well, and it didn't get much better, which indicates that more testing did not give a better outcome or better accuracy. So now I was interested to see how can we make the accuracy better, and one of the items that I was interested in was the age classifier. Do we need a specific age? Do we need to know down to the month or the year of the cat's age, or will using a classifier or an age category of kitten, young, adult, or senior be fine? So using my second model, I removed the specific age and left the age category, and let's see if that makes the model better, which it doesn't. It actually made the accuracy worse at 66% accurate. Which indicates that indeed people are not just interested in a kitten that is either 3 or 6 months, or a cat that is 3 years or 5 years old. The specific age does impact the adoption outcome of the cat. So then I was interested in another variable. Do people care about the color of the cat? So if I remove the variable color, how does that impact the model? So you can see I left all the variables the same except took out color. And then I'm going to run it again. And it has about the same outcome as the original data set. So it got slightly better. Color doesn't drastically impact if the cat is going to be adopted or not, but it doesn't make it worse either. So color doesn't impact adoption too much. And then I was interested in if we make the outcomes easier to choose, and instead of having all of these outcomes listed here, if we only had 2, how would that impact the model? So choosing 4, I left all the variables the same, but for outcome type, I have adoption and not adopted, rather than all the other variables of not adopted. And if we run this again at 50%, the model does get significantly better at 81%, which made it easier for the model to decipher what was adopted and what was not, compared to just the original data set of all the options that could happen for the animals.